Alright, so in this video we're looking at solving rational equations, but this time it's the more challenging ones, okay? So, as we are trying to solve this particular equation, we do need to keep in mind, of course, the skills of solving equations. We want to get a common denominator, and the way I like to do is I like to cancel out all of the, multiply everything by the common denominator and cancel out things that aren't in common. So first I want to kind of rewrite these denominators. So one, this denominator here is written backwards, right? The a is not negative, and I want to rewrite the last one to be a factor. So what I'm going to do is I am going to take out a negative from the bottom to make that an a minus 4. Okay, by making that an a minus 4, I pull out that negative. If I were to distribute back in, then that would flip that, okay? And then the bottom down here would factor to be a minus 4 and a plus 3. If you notice, this two negatives turn into a positive. This denominator has a plus 3. The second denominator is a minus 4. And the last number has an a minus 4 and an a plus 3. So that right there lets us know that our common denominator is a plus 4 times a plus 3. So what I'm going to do is I'm going to multiply every single term by a plus 4 and an a minus 3, and then simplify after that. When I multiply the it's a minus 4 over here. It's a plus. The a plus 3's cancel out, leave me with the 2a minus 4. The a minus 4's cancel out here, leave me with the 3a plus 3. And lastly over here, both a minus 4's and a plus 3's cancel out, leaving you with just 2a minus 2. After that, it's a little bit of algebra. Distribute. Combine like terms. Get your variable on one side. And I find out that a equals negative 1. Now, of course, you always want to check by plugging into the original. Okay? Remember to subtract this. You can do like the little cross thing. Okay? So that's going to be 10 minus 6 over 10, which is 4 over 10. Two negatives make a positive, which is 4 over 10. So yes, a equals negative 1. Here, every single denominator is different. So my common denominator is going to be 20 times x plus 1. So I'm going to multiply every term by that. By a 20, by an x, by x plus 1. The order doesn't matter because we're multiplying here. X plus 1 cancels out, leaving me with the 20 times an x times another x minus, now I'm subtracting this entire second term after I cancel out what's in common. Okay, so I'm going to put another parentheses, and I'm going to see I have an x minus 1 times the 20 times the x plus 1. The 20's cancel out here, and I'm left with the 1, which I'm not going to write, and then just an x times an x plus 1. Again, after that is algebra. I'm going to go ahead and distribute this 20 into the x plus 1. So that way I can FOIL that middle part. Just going to keep simplifying here. FOIL. And what I notice when I FOIL here, I have an x, 20x and a negative 20x that cancel out. So I have a 20x squared. I'm going to distribute the negative to everything. It's going to give me a negative 20x squared and a positive 20. Remember, a negative and a negative make a positive. Look again. I got some more stuff that cancels out. Sometimes, even though it may be a little bit more involved, stuff starts canceling out and makes it really nice. So I basically have 20 equals x squared plus x. And if I get everything to one side, I have a quadratic in which I can solve. This factors down to be x plus 5, x minus 4 equals 0. So I have two potential solutions, x equals negative 5 and x equals 4. But of course, I want to check. So I'm going to plug into the original. I get this by plugging in negative 5. Two negatives make a positive. Two negatives make a positive. I'm going to multiply doing the cross thing, so it's going to be 25 minus 24 all over 20, which is indeed 1 over 20. So I know that 5 works, negative 5 works. Uh-oh. I want to check 4. Okay? Because I need the original equation. I went down too far. So it's going to be 4 over 5 minus 3 over 4 equals 1 over 20. Do the cross thing again. 16 minus 15 over 20, which is, yes, 1 over 20. So they both work. Last one. Common denominator here is an x minus 2, x plus 2, 1. So I'll multiply every term by that. X minus 2, 2x plus 1. X minus 2, 2x plus 1. So this is what I'm left with. And again, it's just algebra from here. FOIL. I'm going to FOIL this first, and then distribute the 3 after. Got some stuff that cancels out. Combine like terms, I got 5x squared, negative x, minus 13. Distribute that over. Oh, just combine like terms, huh? It's going to give me a negative 3x, so when I multiply by 3, it's going to give me a negative 9x, minus 6. And I'm going to get everything to one side. I'm going to subtract the 5x squared from both sides. So I get x squared. I'm going to add the x to get a negative 8x, and then I'm going to add the 13 to get a positive 7. This can be factored. So then x equals 7 and x equals 1. Of course, you know it. Check. 7 minus 1 is 6. 7 minus 2 is 5. 7 times 3 is 21. Plus 6 is 27. 7 times 2 is 14. Plus 1 is 15. Try to see if that equals 3. So I'm going to cross and then to add them together. So 6 times 15 is 90. 5 times 27 is a 135. 5 times 15 is 75. I have 225 divided by 75, and yes, indeed, that is 3. I'm going to check 1 over here in this open space. 1 minus 1 is 0. Okay, so that's actually kind of nice. That's already 0. 3 times 1 is 3, plus 6 is 9. 2 times 1 is 2, plus 1 is 3. 9 over 3 is indeed 3. So these both actually work out as my final solution.